Every single night, while most of the world is asleep, something remarkable happens above the Atlantic Ocean. Hundreds of aeroplanes, carrying more than 300,000 people in total, begin crossing one of the most dangerous stretches of water on Earth. They fly in the dark. They fly in extreme cold. They fly through winds that can reach 300 kilometers per hour. And they do it in long, thin lines, just a few kilometers apart from each other. If you have ever looked out of a plane window at night and seen nothing but black ocean below you, you were part of this system. But why does it happen at night? The answer is not as simple as you might think. The night sky over the Atlantic is not empty. It is one of the most organized, carefully planned spaces on the planet. Most people think it happens because passengers want to sleep on long flights. You board the plane in the evening, close your eyes, and wake up in a new country. But here is the truth: passenger comfort is not the main reason. The real reason is something much more interesting, and it lives high above your head, in the cold sky over the ocean. When a plane flies over land, it is never alone. Air traffic controllers on the ground can see it on their radar screens at all times. But when a plane flies over the Atlantic Ocean, that safety net disappears. There are no radar stations in the middle of the ocean. The pilots send position reports by radio, but these come at intervals, not in real time. Every decision must be made in advance. The North Atlantic is the busiest oceanic airspace in the world. During peak hours, more than 100 aircraft per hour cross it, all without continuous radar contact. Because of this, the people who manage Atlantic airspace came up with a very precise system. Every day, they look at the weather, the winds, and the number of planes expected to fly. Then they draw a set of routes, usually between 5 and 10 of them, across the ocean. These routes are like invisible roads in the sky. Each one is a chain of exact points, and every plane that flies on that road must follow those points perfectly. It must arrive at each point at exactly the right time. 1 minute early or 1 minute late can cause serious problems, because dozens of other planes are following just behind. This system is called the North Atlantic Track System, and it is rebuilt completely every single day based on current conditions. Now here is where night becomes important. High in the sky, at the altitude where passenger planes cruise, there are powerful rivers of wind called jet streams. These are not gentle breezes. They can blow at speeds of 200, 250, sometimes even 300 kilometers per hour. A plane that flies with a jet stream behind it can cross the Atlantic much faster. A plane fighting against one will be slowed down significantly. On a normal day, a plane flying from North America to Europe can save an hour or more just by finding the right jet stream. The problem is that jet streams move. They change position, change strength, and change shape. During the daytime, the sun heats the atmosphere, and the air becomes active and unpredictable. Winds shift. Turbulence forms in unexpected places. Conditions change faster than planners can update their calculations. For a system that requires extreme precision, an active, changing atmosphere is a serious challenge. But at night, without the heat of the sun, the atmosphere calms down. The jet streams settle into more predictable paths. Planners can calculate the best routes with much greater confidence. This is why the main rush of transatlantic flights happens at night. It is when the sky is most cooperative. At night, the atmosphere stops its daytime restlessness. The winds become predictable. And that predictability is worth everything. Here is something you may have noticed if you have ever flown across the Atlantic in both directions. The flight from North America to Europe is usually 1 to 2 hours shorter than the return journey. It is because of those jet streams. Planes flying from New York or Toronto to London or Paris are often flying with the wind pushing them from behind. Planes going the other way must fly into those same winds, which slows them down. In February 2020, a Boeing 747 flew from New York City to London in under 5 hours. The plane itself was not flying unusually fast. Its engines were doing the same job they always do. But it had caught an exceptionally strong jet stream that pushed it across the ocean at over 1,000 kilometers per hour. That is the power of flying at the right time, on the right route, in the right direction. By contrast, the absolute record still belongs to Concorde. Sometimes a plane is physically capable of flying faster, but the system does not allow it. The pilots receive an instruction to reduce their speed. Why would anyone slow down a plane that could be going faster? The answer is spacing. If one plane speeds up, it gets closer to the plane ahead of it. That breaks the required distance between aircraft, which is a safety violation. The most important thing is not speed, it is order. Inside this system, discipline matters more than performance. If a transatlantic flight arrives just 30 minutes earlier than scheduled, it can improve the entire day's operations for that aircraft. When you sit in that seat at 35,000 feet and look out at the black ocean below, what you are actually seeing is the result of decades of science, planning, and international cooperation. Meteorologists study the jet streams. Route planners draw the tracks. Air traffic controllers from multiple countries coordinate the handover of each plane as it moves through different zones of the ocean. Pilots fly with precision that most people never think about. And the atmosphere itself decides whether the night is easy or difficult. The next time you board a transatlantic night flight, think about what is happening outside that small oval window. The darkness is not empty. It is full of organization, physics, and an extraordinary human system. The night was not chosen for comfort. It was chosen because the sky is calmer, the winds are more reliable, and the mathematics of movement become a little more forgiving. The Atlantic at night is not just a flight path. It is one of the most carefully managed corridors in the history of human movement.